Okay, I'm starting the class. So today we will discuss about the two topics. One is storage oscilloscope, and next one is digital storage oscilloscope. Okay, so this is a digital storage oscilloscope. So this is the digital storage oscilloscope. So digital storage oscilloscope. So before going to digital storage, storage oscilloscope, you need to know about the this basic CRO. Okay, so basic CRO added with some more components, it becomes a storage oscilloscope. So if you see the basic CRO, it consists of input signal. Okay, this is the input signal, and it is given to the vertical amplifier. So it is given to vertical amplifier, and it is coming to the delay line. From the delay line, it is coming to the vertical deflection plates. Okay, so that means in order to vary the voltage vertically, we are using vertical deflection plate. And from here, there is a triggering circuit. So the purpose of triggering circuit is in order to synchronize both vertical and horizontal deflection plates. You have a triggering circuit, and it is given to time based generator. It will generate a sawtooth or time based waveform, so sweep waveform, which is called as a ramp or sweep waveform. This is a known signal, and it is given to the a horizontal amplifier, and it is from the horizontal amplifier it is given to the horizontal deflection plate. And through so this is electron gun. So electron gun is passing through vertical deflection plates as well as horizontal deflection plate, and it will strike the phosphorus phosphorus screen. Okay, so this is a waveform. Whatever the waveform, suppose it is a sine wave, the waveform will be displayed on a fluorescent screen. Okay, so this is the basic diagram for CRO, the basic CRO. So, basic CRO. So coming to the storage oscilloscope. So the storage oscilloscope. So that means in the basic CRO, suppose if you switch off and switch on, so whatever the waveform, input waveform or output waveform you want to see, that means if you remove the probe, the input waveform will go. Okay. So suppose if I want to store whatever the previous waveform, so I can use this storage oscilloscope. That means the storage oscilloscope are able to retain a wave pattern for long time. So it will store the previous waveform for the long time. So in that situation, we are using this storage oscilloscope. So there are two types of storage oscilloscope. One is mesh storage, and next one is phosphor storage. So mainly in this class, I will explain you about the mesh storage oscilloscope. Okay. So mesh storage is used to display very low frequency signals. So in order to display very low frequency signals, we are using mesh storage oscilloscope. Okay, so if you see the mesh storage oscilloscope, the additional things are so you have storage mesh, and next you have collector mesh. Basically the main parts are this flood gun. Okay, these are the main things which are present in the storage oscilloscope. And collimator means in order to bring the electrons parallelly, we are using collimator. So the main things are these three things: flood gun, storage mesh, and collector mesh. Okay, these are the main things which are present in the storage oscilloscope. So as you know, in the normal oscilloscope, normal CRO, so this is the electron gun, vertical deflection plates, and horizontal deflection plates, and this is a phosphor screen. Okay, these are present in normal CRO. Okay, so normal CRO, you have these things. So additionally, along with this normal CRO things, we are added uh, these things present in the storage oscilloscope. Okay, so these are the things present in the storage oscilloscope. So coming to the mechanism. Okay, so you have a mesh storage, no? So you have mesh storage CRT that contains a dielectric material. So it contains a dielectric material which is deposited on the mesh storage. So whatever the dielectric material is there, that will be deposited on the mesh storage. So there are so the dielectric material is basically magnesium fluoride. Okay, it's a magnesium fluoride. So there are two properties of magnesium fluoride. Okay, so one property is nothing but secondary emission. So that means when you are emitting a electrons to this magnesium fluoride, so that electrons will collide, and this magnesium fluoride will reproduce a secondary electrons. Okay, it will produce. So that means primary electrons will be collide in the magnesium fluoride, and it will produce a secondary electron, and that secondary electrons are produced by a positive. That means that will be produced by positive side. Okay, and good insulating property means uh, this will uh, this will localize these electrons, secondary electrons, in order to uh, means in order to pass or total dielectric, that means in order to expand whole dielectric, it will localize this secondary electrons. So one is the secondary emission. So secondary emission means secondary electrons will be emitted, and insulating property means it will localize the secondary electrons. Okay, so in order to expand whole dielectric, it will localize the secondary electrons. Okay, so these are the two properties of the magnesium fluoride. Okay, so we'll see the diagram. So see here, suppose here this is a electron, this is a electron gun. From the electron gun, electrons are flowing, and this is a phosphor screen, and here you have mesh storage. Okay, mesh storage, you have magnesium fluoride. So some the sine wave is creating over here. Suppose uh, so whatever the sine wave is creating on the mesh storage, that will be displayed on the phosphor storage. Okay, sorry, phosphor screen. Okay, it will be displayed on the phosphor screen. Suppose if you stop the emitting of electrons from the electron gun, so whatever the waveform is there, that will be stored in the stored in the this mesh storage. Okay, suppose if you want to see again, so whatever the waveform present in the mesh storage, that will be again displayed on the phosphor screen. Okay, so that means it will store the previous waveform in this mesh storage. After, if you again power on this storage oscilloscope, whatever the waveform it is stored, that will be displayed on the phosphor screen. Okay, so see here, producing the storage pattern. So here you have the right gun, and you have here flood gun. So flood gun will emit the electrons. Flood gun will emit the electrons. Here this is the phosphor screen, and this is storage mesh, and this is collector mesh. So in between flood gun and storage mesh, you have collector mesh and collimator. So what is the purpose of collimator? Collimator will maintain these electrons to pass through to the storage mesh parallelly. Okay, so that is the operation of the collimator. Okay, so if you see, so that means here so some waveform. So due to this flood gun, electrons are flowing through collector mesh, and the waveform is displayed on the storage mesh. Okay, so so whatever the waveform displayed on the storage mesh, that will be displayed on the phosphor screen. Okay, so that means so when the electron gun is passing the electrons towards this one. So if you remove this electron gun, that means when you switch off this CRO, so whatever the previous waveform is there, that will be stored in the storage mesh, and that will be again displayed on the phosphor screen. Okay, this collimator will maintain these electrons to pass through this collector mesh and storage mesh parallelly. Okay, that is the operation of the collimator. So this is the reproducing the storage pattern. So here if you see, so these are the this is collector mesh, and this is storage mesh, and this is the phosphor screen. So here from the flood gun, electrons are coming to the collector mesh, and it is some electrons will be uh, here accumulated, and here it will be accumulated with the storage mesh. Suppose here some that means some positive charges are there. That means these are the secondary electrons. So secondary electrons are there. So due to these secondary electrons, so there is a potential difference between the storage mesh and collector mesh. Both are same. Some electrons will be passed. That means some electrons will be due to electric field. Some electrons will be passed from the storage mesh towards the phosphor screen. Okay. So due to this positive charge, some electrons will be uh, flowing from storage surface, storage mesh to the phosphor screen. That means a previously stored whatever the stored waveform is there, that will be, suppose sine wave is there. The sine wave is stored in storage mesh. The same sine wave will be displayed on the phosphor screen. So this is how the mechanism will work. So whatever the storage waveforms are there, that will be displayed on the phosphor screen. Okay. So see here. So the electrons will be here. There is no accumulation. Due to the secondary electrons, due to positive charge, electrons will be attracted, and this will be passed through the phosphor screen. So this is about the storage oscilloscope. And next we will see the digital storage oscilloscope. Okay. So digital storage oscilloscope. Digital storage oscilloscope is defined which stores and analyze the signals digitally. That means if you want the signals in terms of ones and zeros, so we'll use a digital storage oscilloscope. That means preferably we'll use this ones and zeros. Okay. So whatever the analog signals are there, that will be displayed digitally. Okay. So that means what it will do, digital storage oscilloscope will takes the input signal, stores them. So you have the memory in digital for storing the digital values. You have memory, so memory in inbuilt memory, and whatever the inputs are there, that will be displayed on the screen. Okay. So digital oscilloscope has advanced features. So what are the advanced features compared to the normal oscilloscope? Means it consists of storage, triggering, and measurement. Okay. So these are the additional features which are present in digital storage oscilloscope. So coming to the basic simple means basic block diagram. So digital storage oscilloscope consists of a sample and hold circuit, ADC, and display. Okay. So ADC and display. So if you see the functionally, what is the function of sample and hold circuit means, functionally saying it's a switch with a capacitor. Okay, it's a switch with a capacitor. So that means so you have a switch with capacitor. So that means what you are doing, you are you first, when you are opening the switch, there is no voltage present in the capacitor. So you're so that means when the when switch is open, so this is the waveform. So what you are doing, you are closing the switch and immediately you are opening the switch. So that means when you are closing the switch, what happens, capacitor will charge. Whatever this capacitor is there, that will be charged to, suppose vi of t is there, so it will charge to the time, instantaneous time, it will charge to t naught. Okay, it will charge to t naught. Okay, after that what you are doing, you are opening the switch. That means it will be again it will come to the open state. Switch is open means again it will discharge. Okay. So see here. So that means what you are doing, so here first switch is open and is closed, and for time duration tau, what you are doing, again you are closing the switch for time period t plus t naught plus tau. Okay. And next, after that, again what you are doing, you are closing the switch for t naught plus 2 tau. Okay. So like that. So that means every time you are closing the switch and closing the switch like that, so you will get a different voltage, different voltages. So the you will get a pulse over here. Okay. So that means vi plus t naught, vi plus vi t naught plus tau, vi t naught plus 2 tau, up to so on n times you are switching, you are closing or opening the switch means you are getting vi t naught plus n tau. Okay. So this is the mechanism of a sample and hold circuit. Okay. So see here. So that means what you are doing, after that it is given to the ADC. So what the ADC will do, whatever the pulses are there, it will convert, it will quantize the given signal, and it will convert the given signal, analog signal, to the digital signal. So this is the output of the digital signal. So you are getting at Vi plus Vi of T naught, you are getting this point. Vi of T naught plus tau, you are getting this point, and Vi of T naught plus 2 tau, you are getting this point. So if you join these points, you will get this type of waveform. Okay, so that means tau is nothing but sampling period, and 1 by tau is nothing but the sampling frequency. Okay, so that means you are sampling the given signal, and what you are doing, you are holding that signal. Okay, that's why you sample and hold circuit, and after that you are giving to the AD. Okay, so that means here what you are doing, these are the switches, that means sample and hold circuit, output of sample and hold circuit, and this is the input waveform. So that means you are getting the points at a different point. That means you are converting this given signal to sample the signal. So you are getting discontinuous points over here. So so you are getting discrete time signal. That means discretized. You are making this time signal as discontinuous. So discretized. Okay. So this is the basic operation which is present in the digital oscilloscope, digital storage oscilloscope. So this is the basic block diagram. Uh, so if you see the inbuilt detailed basic block diagram, so you have an input signal and input attenuator and amplifier. So that means basically for a CRO and normal CRO, you have an input attenuator and preamplifier is there, no? So input attenuator, so it will attenuate some high frequency signals or high signals. So what the operation of amplifier? It will amplitude. That means it will amplify the given signal, and after that it is given to the sample and hold circuit. So what it will do? It will discretize the given analog signal. Okay, so that means and hold the signal. Okay, so discretize the basic analog signal means, suppose this is a square wave, so it will discretize. That means it will make the pulses over here, and after that it will hold the signal. Hold the signal means you will get a series of pulses over here. So this is the operation of sample and hold circuit. So series of pulses you are getting in the output of sample and hold circuit. So what the ADC will do? ADC will convert this sample and hold circuit, this pulses, to digital signal. Okay, so first analog signal to discretized and a series of pulses, and after that it is given to ADC. It will convert the given series of pulses into digital signals, ADC, and output of the ADC is a digital data, no? So data input, it is given to memory. Okay, output of the memory means if you want to store some digital values, that will be stored in the memory, and this is data out. Okay, and coming to the horizontal, this is given to the vertical deflection plate, no? So coming to the horizontal deflection plate, you have trigger circuit. This is a trigger circuit. What is the purpose of trigger circuit? This trigger circuit will synchronize both horizontal and vertical deflection plate. That means if you want to vary the horizontal voltage or vertical voltage, though both voltage should be synchronized. So how it will be synchronized means by using triggering circuit. Okay, and next coming to the control logic. So mainly the control logic is it's a microcomputer, a microprocessor. Okay, so microcomputer and microprocessor. So what it will do? It will control. That means it will process. So it is connected to sample and hold circuit, and it is connected to ADC, and it is connected to memory. So it will control the sample and hold circuit with how much of sampling period the signal should be sampled, or it will control the ADC, and it will control the memory. Okay, so this is basically a microcomputer or microcontroller. Okay, and it is given to the output of the control logic is anyway the microprocessor is a digital. It is a digital. So it is given to, so the output memory is data out, digital one. It is coming to D2A converter, and the output of control logic is also a digital. It is given to DTA converter. So what the DTA converter will do? It will convert given digital signal to the analog signal. Okay. So whatever the digital signal is there, that is will be converted into the analog signal. Okay. So okay. So it is given to the vertical amplifier. So vertical amplifier. So through the vertical amplifier, it is given to vertical deflection plate as well as horizontal deflection plate. So see here. So working principle: digital oscilloscope digitizes and stores the input signals. Okay, it will convert the given signal into digital form and stores the input signal in the memory. This can be done by the CRT and digital memory. So the block diagram is shown in figure. So whatever I explained in the block diagram, so this will be shown in terms of this. See here. Digital oscilloscope is there. Digital oscilloscope is an electronic instrument that is capable of storing digital form. So whatever the waveforms are there, that will be stored digital form. So of a measuring waveforms. So this is DSO. Digital DSO is an advanced CRO to overcome the drawbacks of CRO. So what are the drawbacks of CRO? Suppose if you we can't see the digital values in normal CRO. Okay, and whatever the waveforms values are there, that will be previous waveform values are there that we can't see. Only we present waveform values we can see in the normal CRO. So the previous values also we can see in the digital storage oscilloscope. Okay, so here if you see the block diagram, so input waveform is applied to input attenuator and vertical amplifier to bring the measurable form. So see here. So input is applied to input attenuator as a and a vertical amplifier. Okay. The amplified input from the vertical amplifier is passed through sample and hold circuit and unlocked to digital converter. Okay. So whatever the waveform you are getting, that is given to sample and hold circuit as well as A to D converter. Sample and hold circuit samples the input signal and A to D converter digitizes. Okay, so it will convert the sampled signal to digital form, and the input waveform to create data set which will be stored in. So whatever the analog to digital, whatever the digitized digital signal is there, that will be stored in. Can you mute anyone? So see here. So we are seeing the block diagram. So the input signal is coming to the attenuator and vertical amplifier. So and it is given to sample and hold circuit. So what the sample and hold circuit will do? It will convert. It will discretize the given signal, and it will convert the discretized signal into series of pulses. That means it will sample the given signal and it will hold the signal. Okay, it will hold the signal, and next it is given to the A to D converter. So A to D converter, what it will do? It will digitize the given signal. It will convert the series of pulses to digital signal, and it is digital signal is given to the memory. So whatever the digital data is there, that will be stored in the memory. Okay, so some digital data is there that will be connected to the control logic. So see, so sample and hold circuit is there. So this samples the input signal. Okay, it samples the input signal, and A to D converter, what it will do? It digitizes the input waveform and create data set which will be stored in the memory. So whatever the digital data is there, that will be converted, and that will be stored in the memory. Okay, so once the data is stored in the memory, okay, many manipulations are possible as memory can. That means what the memory can do? it can read the data or it can write the data. Okay, so that means memory can read the data or memory can write the many manipulations memory can do. So many manipulation will be done possible in the memory. Okay, so whatever the data uh, which is stored in the memory, that is given to the control logic. Okay, so what is our control logic? As I told you, control logic is nothing but the, what is our control logic? Control logic is nothing but it's a microprocessor or microcomputer. It can be microcontroller or microcomputer. So that means basically it will process the digital data. So here the data is processed by the control logic, which is basically work as a, it will work as a mini computer. So mini computer means it is basically microprocessor. It is a microprocessor. Okay, and next control logic controls the functioning of sample and hold circuit, analog to digital converter, and memory unit. So if you see the diagram, control logic is connected to this sample and hold circuit. Okay, and next to A to D converter, it is connected to A to D converter, and it is connected to the memory. Okay, so it will controls sample and hold circuit, and it will controls the A to D converter, and it will controls the memory. Okay, so and digital storage oscilloscope is a electronic instrument that is capable of storing. Sorry. Uh, so see here, uh, the read operation is memory device is controlled by what? Memory unit. So whatever the read operation is there, that will be controlled by memory unit. Timing and mode logic is used to decide the timing and mode operation. So that means whatever the timing signals are there, that will be controlled by control logic and trigger circuit. Okay, so trigger circuit is mainly used to synchronize both horizontal as well as vertical amplifiers or vertical deflection plates. Okay, uh, digital data from the memory and from the control logic is then converted to analog form and passed through the vertical deflection plate of amplifier and horizontal deflection plate of amplifier. Why? Because parallelly we can by using digital oscilloscope we can generate the digital signals. Okay, by using ADT converters, and we can also observe the analog signals in the CRT. Okay, so whatever the digital data is there, that is again the output of the memory is given to DTA converters, and the output of the control logic is given to DTA converters. So what the DTA converters will do, this will convert again the digital data to analog data. So that analog data digital oscilloscope want to display on the CRT screen. So for displaying the analog signals, we need to so it will convert digital data to the analog signals by digital to analog converter, and it is given to the vertical amplifier and horizontal amplifier in order to amplify the given signal. If it is a low signal, in order to amplify, we are using this vertical amplifier and horizontal amplifier, and it is given to the deflection plate. Okay, so vertical deflection plate and horizontal deflection plate. So see here. So here same thing. Digital data is there, that is again converted to analog form by passing analog form by using DTA converters, and again it is given to the horizontal deflection plate as well as vertical deflection plate. So horizontal and vertical signals are fed to horizontal and vertical deflection plate. Okay. So whatever the analog signal is there, that will be displayed on the CRT screen. So whatever the digital data is there, that is will be stored in the memory, and digital data is given to D2A converters, and DTA converters will what it will do, it will convert the digital signal to analog signal. Again that analog signals are given to analog horizontal and vertical amplifiers. Through the vertical amplifiers and horizontal amplifiers, it is given to horizontal and vertical deflection plates. So through the deflection plates, so whatever the analog waveform is there, that will be displayed on the CRT screen. Okay, so this is the whatever I explained in the block diagram. So that is a display that is explained in terms of uh, these points. Okay, so coming to the modes of the operation. So there are it will be operated in three modes of operation. So DSO, digital storage oscilloscope, will be operated in three modes of operation. One is roll mode, and next one is store or refresh mode, and next one is hold or save mode. Okay, so we'll see these three modes one by one. So coming to the roll mode, okay. So this mode is used to display fast varying signals clearly on the screen. Suppose fast varying signals are there. If you want to measure some at a particular point, if you want to measure some frequency or time, frequency or amplitude, so that fast varying signals can be clearly seen on the roll mode. Okay. So what we do? What the we can do in the roll mode? Whatever the fast varying signals are there, that displayed slow mode on the screen. So fast varying signals are there, that will be displayed slowly. Okay. So if they are displayed slowly means we can able to measure any parameter, either frequency or time period. Okay. So the whatever the input signal is there, that will be not triggered at all time. Okay. That will be not synchronized at the all time. Okay. So stored signal is rolled slowly from right to left across the screen. So from right to left. So suppose this is a screen. So so if it is a sine wave, that will be displayed from from right to left. So that means from right to left it will be displayed. So it will be displayed slowly. Okay. So that means fast varying signals are there, that will be displayed slowly. Okay. And store and refresh mode. So this is one of the important mode which is present in digital storage oscilloscope. So this is mostly commonly used uh, mode. Okay. So in this mode, the input signal initiates the trigger circuit, and trigger circuit initiates the memory write cycle, and digital data is stored in the memory. Okay. So here you have the trigger circuit. No, if you see in the block diagram, you have the trigger circuit. No, so in this mode it will initiate the trigger circuit. Okay. So when it initiates the trigger circuit, what happens? So what happens when it initiates the trigger circuit? Trigger circuit initiates the memory cycle. Okay, it initiates the memory cycle. So whatever the digital data is there, that will be stored in the memory. Okay, so this trigger circuit initiates the memory. Okay, and when memory is full, okay, write operation stops. So whatever the data, digital data is there, that writing into the memory, that will stop when the memory is full. Okay. So digital to analog converter converts the stored data in analog form, which is displayed on the screen. So that means whatever the digital data is there, that is converted to the analog form by using D2A converters. Okay, and it will be displayed on the CRT. And when next trigger occurs, what happens? Whatever the data is writing into the memory is refreshed. Okay. So memory is refreshed, that means memory is cleared. Again it will trigger circuit initiates the memory, and it will write the data into the memory. Okay. So this is how the storage store or refresh mode, whatever the data, so in the name itself it is there, the data will be stored in the memory. So trigger circuit initiates the memory, and whatever the digital data is there, that will be stored in the memory. And after next triggering, every time that memory will be refreshed. Okay. And next, hold and save method. You see the hold and save method. This mode is operation is also called as automatic refresh method. So this is automatic refresh method. So it is referred to the triggering circuit. Okay. So new sweep, that means new sweep is generated at time based generator. So that means if you see the time based generator, so where is the time based generator? So this is the time based which is coming to the horizontal deflection plate. That is nothing but time based generator. No, it will generate the sweep or sweep waveform. Okay, or sawtooth ramp waveform. So here what happens? So see here. Mm, so old content override the new content. When you are getting a new sweep, when you are getting a new sweep, old whatever the old content is there, that will be overwritten by the new content. Okay, that will be overwritten by the new content. So particular signal to be stored, then pressing hold or save button, overwriting will be stopped, and previously saved signal will be logged. So that means if you want to see the previously saved data, so what you should do, you should press uh, hold and save button. Okay, so when you press hold and save button, what happens? So whatever the overwriting data is there, overwriting data will be stopped. Okay, and previous data is there, whatever the previous data will be there, that will be locked in hold and save mode. Okay, so this is basically single shot events when it is transient in nature and when quickly disappear. Transient in nature means it's like a spike. Suppose if you want to see a spike of waveform, okay, like spike of waveform, so you can use this hold and save mode. Okay, so in summary, I can say that roll mode means we can see the fast varying signals in slowly. Okay, it will show slowly, and we can find out the whatever the parameters. And store and refresh mode means whatever our trigger circuit is there in the digital storage oscilloscope, the trigger circuit is there. The trigger circuit will initiate the memory, and whatever the digital data is there, that will be data. The data will be right into the circle. Sorry, right into the memory. Okay, when the memory is full, what happens? It stops operation. So for every triggering, the memory will be refreshed. Okay, and in this store and save mode, whatever the digital data is there, it is given to the DAC, digital to analog converter, and it is displayed on the screen. Okay, through vertical and horizontal deflection plate. And hold and save mode means uh, here whatever the old content is there. Okay, old content will be saved. So this is automatic refresh mode. So it is synchronized with the time based generator. So when new time based generator occurs, old will be overwritten by the new one. Suppose if you want to see old one, what you should do? You should press a hold and save button. So whatever the overwritten data will be there, that will be stopped, and previously saved data will be locked in this hold and save mode. Okay. So this is about the uh, storage uh, storage and